Okay, so the first one is 16. So for 3 in a pie chart, why are the slices or sectors different sizes? That would be each slice represents a category, and the area of each slice represents the proportion of the total occupied by the category. Question 4, how are bar charts and Pareto charts related? The only difference between a bar chart and a Pareto chart is that the bars in a Pareto chart are ordered largest to smallest, going from left to right. And then use this information for the next 3 questions. Question 5, is P the true proportion or the sample proportion? That would be true proportion. What is N? It's the sample size. For 7, if P equals 1/4, what is the smallest N that satisfies the requirement? So all you have to do for that is you have the equation is NP greater than or equal to 10, so you just do 10 divided by 1/4 and you get 40. And then for 8, what is the mean of P? So you just take the mean is just P equals 0.4. And then for 9, what is the standard deviation of P? That's where you take the square root of 0.4 times 1 minus 0.4 divided by the sample size of 24, and you should get 0.1. And then for 10, what is P, which is 0.35? You got to do 0.3 divided by 100 for this one. And then what is the standard deviation of that? So you do the the square root of the 0.35, no, 0.3, and then times that by 1 minus 0.3 and divide by 100. And you should get 0.046. And then what is the z-score? So there's an equation for that one. So you just do the value minus the mean divided by the standard deviation. And then that should get you 1.087. And then 13, what is the probability Brittany gets at least 35 hits in her next 100 at bats? So you just plug 1.087 into the normal probability applet, and then highlight just the right tail. And then you should get 0.139. And then 14, what is the standard deviation of P? Let's continue to do that same equation that we've been doing. 0.011 should be the answer for that. And then question 15, what is the z-score? Just the value minus the mean divided by standard deviation, and that should get you negative 1.818. And then 16, what is the probability the survey results will show the candidate is losing even though the true P equals 0.52? So you just plug negative 1.818 into normal probability applet, and then I highlight just the left side, and you should get 0.035.
All right, thanks. So for 17, let me pull that up real quick.
Okay.
We get, for question 3, the symbol for true population proportion is the third option, P, because P hat is the point estimate for it. For the next 2 questions, suppose that N is 100 and P is 0.25 and P hat is 0.1. So the requirements for constructing confidence interval are satisfied. That is true. And we can find that out by our 2 requirements is N greater than 10, and it is, and is where'd it go? Is N times 1 minus P greater than 10, and when you plug that in, it is. The requirements for conducting a hypothesis are satisfied because both conditions are fulfilled. For question 6, find P hat, the point estimate proportion of the first degree murder defendants who are found guilty in the state, and that's 0.11. L16-17, determine the margin of error for this 95% confidence interval, and that's also 0.11. And margin of error is calculated by our z-score times the square root of p hat times 1 minus p hat divided by population. And so then the lower bound would be p hat plus this value we just found, this margin of error, and that's 0.64. And then the upper bound, that would be subtraction. The upper bound is the addition portion, which is 0.86. If you increase the sample size from 60 to 80, we expect the confidence interval to decrease because there's more. There's a larger population. So it gives us a better estimate about what the true mean is. So to conduct a hypothesis test for one proportion, two requirements must be met, like we talked earlier. Suppose P equals 1/2. What is the smallest n can be for both requirements? Oh, and both requirements still be met. So n has to be at least 10. But we'd find that by doing 10 divided by 0.5, and we get 20. So to conduct a hypothesis test for one proportion, two requirements must be met. Suppose P equals 1/10, and what is the smallest n can be? So we do 0.1, or 10 divided by 0.1, which gives us 100. For 13, the conditions for the hypothesis test are satisfied. That is true, they are, because our n is greater than 10, and so is our n times 1 minus p. What is p hat? And it's 0.475. And then it's asked for find the test statistic. Well, the test statistic is really found by running through the Excel sheet that's provided, and we type in our variables of our x's and n, and it comes up with the value of negative 2.282. So that's our z-score, and because our test statistic is the right tail of the data, we plug that in, and our p-value is 0.011. What is the decision for this test? We reject the null hypothesis because 0.011 is less than 0.05, which is our alpha value. So it fails. So, which of the following best summarizes the conclusion of this test? In conclusion, there is sufficient evidence to conclude that the water quality in this area has decreased because we reject the null hypothesis. It's not equal to what it says it is, and we said for our alternate that it was less than, and there's enough evidence to suggest that there is. And so that's our quizzes. So real quick, we got about 10 minutes left. I just wanted to talk with you guys about our group project and kind of like hammer out some stuff, because we have to turn in a draft by tonight, which I can do. I can turn in the draft, but we just have to come to some decisions as to who's doing what and what kind of test we're doing. You guys up for that for the next couple minutes?
Yeah.
Okay.
Yeah.
All right. So we had, if you go to the design the study, you can find it's a document. Basically, do you guys have any ideas for a test? I know I posted an idea on there, but what do you guys think?
What was it about?
Let's see, what was it?
It was for Domino's, because Domino's pizza is pretty good and it's pretty cheap. Is for their pizzas, are there pepperonis on each slice evenly distributed? So like, you know, per slice, do you actually get the same amount of pepperonis, or are there some slices that have more and some slices that have less? Like, you know, is it not equal? Because I know, like, some slices you get a whole bunch and some slices don't get any. It doesn't seem fair, but like, is it actually fair? Is my idea, but.
I like pizza.
All right. Anyone have cheese or dairy allergies to this, or?
No.
No.
Okay, cool. So for our experimental unit, we'll be using pizza slices, right? Because we're wanting to know if each slice of pizza is evenly distributed, or the pepperonis are evenly distributed on each slice. So we need at least 30 slices of pizza. So I was doing some like figuring out, and if we each get 2 medium pizzas, 2 medium pepperonis, we should all get enough data for 30 slices or more. So, anyways, do you guys have that document pulled up?
Yeah.
Yeah.
Okay, so what we need to decide this time is this is just our first draft. We don't have to have everything set in stone, but we do need to turn in something. And so it says steps 1 through 7, or the first 6 steps there. We need to assign who's the writer for that individual part. So I can do step 1 of writing and designing the study.
I can do step 3.
Step 3, okay.
I can do the take action, step 5.
Step 5, okay. I can do step 4 then. Or
I don't want to PowerPoint.
okay. I'll do 1 and 6. I'll do 1 and 6. I can do PowerPoints. I don't mind doing them.
Okay. Then I'll do step 3 and 4.
Okay. Let me just write this down so we have it to turn in. You spell your name with 2 S's, right, Melissa?
Yeah.
Okay.
So unless you're doing 3 and 4?
Yeah.
Okay, then I'll do 2 and 5 then.
Yeah, everyone has to do 2. That's why we all have to get those. Yeah, that's why we all have to get those pizzas. And then I'll do this one. Okay. Cool. And we have to have him approve it before we can collect the data. So we can't start this until at least sometime next week.
Okay.
But if you guys are cool with that design, that study, then I can write up a draft and send it in.
Yeah, I'm fine.
Okay. So just to double check, step 1 and 6 I'll be taking. Steps 3 and 4 is Melissa, and step 5 will be Amber.
Yeah.
Okay. Cool. Alright, that's everything we had to go over.
Oh, okay.
Yeah.
Really?
Yeah, for now. The rest I just have to go through and fill out. And then once we get his approval, then we can do steps 2. And then once we finish collecting the data, we can it just all falls into place from there. So, and I'll send you guys.
Go ahead.
I'll send you guys copies of the draft as well, so that way we all are on the same page.
Okay. So my only question is for like the design of the study, like what we need to submit for the assignment for this week? Do we just submit what we just filled out right now, or?
So for steps 1 and then 3 through 7, or 3 through 6, is only 1 per group. So I'll be turning it in. But steps 2 and 7, everyone has to do individually and turn in individually. So he said he'd mark us down if we submitted more than 1 of it.
Okay.
So I'll take care of it. You guys don't have to worry about it.
Okay.
So That's all